In the previous video, we talked about the laws of exponents. Now in this video, let's talk about the properties of nth roots. Similar to the properties of exponents, we have the following properties of nth roots. We have the nth root of a product, nth root of a quotient, nth root of an nth root, and nth root of an nth power. Now let's discuss them one by one. So first we have the nth root of a product. Let's say we have nth root of a times b. From the definition of nth root, this equals ab raised to 1 over n. Now from the laws of exponents, this equals a raised to 1 over n times b raised to 1 over n. But again, by definition of nth root, this equals nth root of a times nth root of b. So therefore, we have the following property. The nth root of a product of two numbers is equal to the product of the nth roots of each number. Nth root of ab is equal to nth root of a times nth root of b. Now let's verify this using examples. Let's say we have the square root of 4 times 9. This equals square root of 36, and the square root of 36 is 6. Now using the property, square root of 4 times 9 equals square root of 4 times square root of 9. The square root of 4 is 2, and the square root of 9 is 3. So we have 2 times 3, and 2 times 3 is 6. Let's have another example. Say we have the cube root of negative 8 times 27. This equals cube root of negative 216, and the cube root of negative 216 is negative 6. Now using the property, the cube root of negative 8 times 27 is equal to the cube root of negative 8 times cube root of 27. Cube root of negative 8 is negative 2, and the cube root of 27 is 3. So we have negative 2 times 3, and this is negative 6. So as we can see, we get the same value whether we use the property or not. Now let's move to the next property. Now what if we have an nth root of a over b? From the definition of nth root, this equals a over b raised to 1 over n. From the laws of exponents, this equals a raised to 1 over n over b raised to 1 over n. And again, from definition of nth root, this equals nth root of a over nth root of b. So therefore, we have the following property. The nth root of a quotient of two numbers is equal to the quotient of the nth roots of each number. Nth root of a over b is equal to nth root of a over nth root of b. Now let us verify this using examples. Let's say we have 4th root of 256 over 16. 256 over 16 is 16, so we have 4th root of 16. And the 4th root of 16 is 2. Now using the property, 4th root of 256 over 16 equals 4th root of 256 over 4th root of 16. The 4th root of 256 is 4, and the 4th root of 16 is 2. So we have 4 over 2, which is 2. Let's have another example. Let's say we have square root of 81 over 9. Now 81 over 9 is 9, so this equals square root of 9, and the square root of 9 is 3. Now using the property, square root of 81 over 9 equals square root of 81 over square root of 9. The square root of 81 is 9, and the square root of 9 is 3. So we have 9 over 3, which is 3. So as we can see, we get the same value whether we use the property or not. Now let's get to the third property. Now let's say we have the nth root of the nth root of b. Again, from the definition of nth root, this equals nth root of b raised to 1 over n. And again, by definition of nth root, this time in terms of m, this equals b raised to 1 over n raised to 1 over m. From the laws of exponents, this is equal to b raised to 1 over m times n. And again, from the definition of nth root, this time in terms of mn, then this equals m times nth root of b. So therefore, we have the following property. The nth root of an nth root of a number is equal to the m times nth root of the number. Mth root of nth root of b equals m times nth root of b. Now let us verify this using examples. Let's say we have cube root of square root of 64. The square root of 64 is 8, so this equals cube root of 8. And the cube root of 8 is 2. Now using the property, cube root of square root of 64 equals 3 times 2, or 6th root of 64. And the 6th root of 64 is 2. Let's have another example. Let's say we have square root of 4th root of 256. The 4th root of 256 is 4, so this equals square root of 4. And the square root of 4 is 2. Now using the property, square root of 4th root of 256 equals 2 times 4, or 8th root of 256. And the 8th root of 256 is 2. So as we can see, we get the same value whether we use the property or not. Now let's move to the last property. Let's say we have the cube root of 2 cubed. Now the cube of 2 is 8, so this is cube root of 8. And the cube root of 8 is 2. Now let's say we have cube root of negative 2 cubed. Negative 2 cubed is negative 8. So this equals cube root of negative 8. And the cube root of negative 8 is negative 2. Now it looks like that when we raise a number to n and we get the nth root, we get back to the number. But that is not always true. Let's look at the following. Let's say we have square root of 5 squared. 5 squared is 25, so this equals square root of 25. And from definition of nth root, square root of 25 is 5. Now if we have square root of negative 5 squared, this equals square root of 25. And from definition of nth root, square root of 25 is 5, which is the absolute value of negative 5. So therefore, we have to be careful with this and remember the following property. The nth root of a number to the nth power is equal to the number if n is odd, and is equal to the absolute value of the number if n is even. Nth root of b raised to n equals b if n is odd, and nth root of b raised to n equals absolute value of b if n is even. As another example, the cube root of negative 4 cubed equals negative 4 because n is odd, while the fourth root of negative 4 raised to 4 equals absolute value of negative 4 because n is even. Now let us summarize these four basic properties of nth roots. The nth root of a product equals the product of the nth roots. The nth root of a quotient equals the quotient of the nth roots. The nth root of an nth root of a number equals the m times nth root of the number. The nth root of a number to the n equals the number if n is odd and is equal to the absolute value of the number if n is even. So these are the basic properties of nth roots. Thanks for watching.